I'm so excited to introduce Matt in our conference. Matt is a lead designer of C Sharp, and he's been a PM at Microsoft since 2005. Today, Matt will share some news about development of C Sharp 12. And just to remind, leave all your questions in our Discord chat, and I will definitely ask Matt about that. And let me translate in Ukrainian. Якщо ви маєте будь-які питання любою мовою, задавайте їх в Discord, я обов'язково їх задав Matt. Matt, floor is yours.
Welcome to the last talk of the session for you, the first for me. It's early morning in Seattle, but there's no bad time to be talking about C Sharp. So here we go. I brought a few things to show for the next version of C Sharp 12. Before we just dive in and do some Visual Studio fun, let me just show you a few places that you can go and follow along as we approach the launch of C Sharp 12 and beyond. So here's C Sharp's documentation site. It's actually great. There's all kinds of stuff in here. If you want to follow what's new, there's a whole section here. It's already starting to accumulate C Sharp 12 things. We have over here, for instance, if you're wondering why we keep adding so many things to C Sharp after more than 20 years, what are we thinking? How are we thinking about this? The C Sharp language strategy is a good, concise description of our kind of philosophy for how we evolve our different languages, including C Sharp. So I recommend you go and take a look there. Let me see if I can get the screen sharing thing is actually in the way. Let me move this window a little bit and click on the other tab. So here's the official repo for C Sharp. So the design of C Sharp is open source. The implementation is also open source in a different GitHub repo. But all the artifacts that we use for designing C Sharp are actually shared inside and outside of Microsoft. We have several participants, both in the design and in implementation of C Sharp, that do not work for Microsoft. And everything happens here. So in this repo, this is where new language proposals come in. They typically start here as discussions. People will discuss an idea, a problem in C Sharp. If an idea has legs, we will ask people to write it up more formally and put it up as an issue here. So you can see there are various proposals here. Members of the C Sharp design team can champion a proposal, meaning that the C Sharp design team should look at it. Here's one that I put up recently. And eventually, we will discuss them in language design meetings. So if we look here under code, the language design meetings are documented as well. You can go in and find the notes from every single meeting. And that is where we capture our thoughts about any given proposal or idea or problem with a feature that we discuss in here. So you can see the previous, here's the agenda for upcoming meetings. You can see the previous meetings here. Go and take a look at what were they talking about for collection literals, and get quite a detailed discussion. And this is great for us as well, as we evolve the language and we come back later and say, why didn't we do it this other way? Why did we drop this idea? Why did we make this choice? We have the rationale actually documented here. So anyone can come in and participate here as well. It's a great way to influence the C# language and kind of get into the mindset of it. But I bet most of you are eager to just hear about, well, what are you actually going to do in C# 12? And it's really starting to take shape. Obviously, it's still work in progress. So anything I show you here might be different by the time we ship the actual language. Features I'm not showing, first of all, I'm probably not showing every feature that will end up being there. And also some of these might be pushed further into the future. But I'll give you a picture of our our current thinking, at least. And if you are asking questions along the way, I'll pause and here and there and ask if there are any questions about a particular feature, and I'll do my best to stay on track with time. Okay. So I'm going to start you out with some code that already works in C# 11. There are some new-ish features in here, so you might not all be super familiar with everything if you haven't kept up with the latest. But I'll point out the things that are newish if they're necessary to understanding. So the first thing I'm going to talk about is a tiny little feature that is just essentially removing a small limitation in C# that's been there forever. When you have using aliases in C#, that for some reason the language has always been limited to allowing you to put a name here. So you couldn't just say decimal because it's a keyword, but we've just opened that up. You can say types anyway. You can say types elsewhere. And this one is just sort of cosmetic, right? You could have said the other thing all the time, but it also means that some types that are best expressed or that can only be expressed with special syntax can now be put here. So you could put like a tuple, for instance, if it was decimal, comma string, you can put a tuple type here. And you can use tuple names, name, colon, and all of that. Apparently I can't. Oh, sorry. No, that's not how you put it. I'm just pretending I know C#. I don't really. So you can put string name, decimal grade, something like that, right? You can even have, I wonder if you can have a pointer to a tuple. No, you can't because it's generic. You can even have pointers, right? So you could say decimal star. Sorry. Again, why don't I go use some other language? Oh, it's because I can only use them in unsafe context. But you can actually make using aliases in unsafe context, and then things work. So just cleaning that one up a little bit so that people don't get surprised by what they can't see. It's not really like an addition so much as a removal of a limitation. Now this should really just be decimal, otherwise the rest of the demo doesn't work. Are there any questions about this one actually out there? We could take that quickly. Nope. All right. Let's move on to a bigger feature. So primary constructors is what we call it. In a couple of versions ago, we added the record feature to C#. And as part of records, we allow you something that we call primary constructors, which is that you can put constructor parameters directly on a record class or a record struct. And that what that primarily does is just essentially add constructor parameters directly to the class. But when it's a record, we additionally do a thing where we let those, we automatically generate a property for those parameters if there isn't already a property there. So you can see the ID and name and things are in here as things that become public properties. Now, we've thought for a long time that primary constructors would actually be useful for every kind of class, not just a record. So in C# 12, we're going to allow any class to have primary constructors. Now, the difference though is that it's not, records are a very specific kind of thing. They're like meant to represent data, and records are meant to have like just the public data exposed. But not all classes are like that. And it's very common to want to have constructor parameters that are not exposed as part of the public state of a given class or struct. And so primary constructors, when now that we're adding them for all classes, we're sort of removing the aspect of them becoming public properties. That's a thing that's only for records and record classes and structs, that's sort of like a thing that they add on. But for the rest of classes, you have to do your own exposing of the parameters. So let's actually rename these to lowercase, because they're just parameters now, right? So this one should be named with a lowercase n, and this one should be I don't know why it's sluggish here today. This one should be lowercase, and this one should be lowercase. They're really just parameters. So what does that mean? Well, you can see that you can still use scope here, but as we saw, nothing is exposed. So I have to write my own properties, and I can do that in any usual way. I could say we could make name and an auto property, get set here, but we could make ID a computed property, public int ID, meaning that it has a getter with and it does not have its backing storage here. Like it has a getter that's just computed. Shorthand way of doing that is as an expression bodied getter here. So I can choose whether and how to expose my my parameters, including or I should initialize this one, including not exposing them at all. So I might not want the grades to be exposed themselves, and I'm just using them internally to compute other things. That, for instance, is something that you might do if you think about things like dependency injection, which is common to do with constructors. You get something in that is like your logger or your something or other helper class that you're parameterized with. That's none of the class's client's business. That's an internal detail for the class to use. So you might wonder, so there's a constructor generated for these parameters. And you might wonder, what happens, how am I able, obviously a constructor parameter can be used for initialization, that makes sense. How am I able to access ID from inside of the body of a property after the constructor has finished running? And that's essentially what the mechanism we call capture, and that's what you already know from Lambda expressions, for instance, that can use surrounding parameters and locals after the enclosing method has already finished running. We simply capture, hold on to whatever values are necessary to keep around for later. So while name is really just a constructor parameter, ID is actually captured as part of the state of the object. So even though you don't see a field here, it's implicitly a field. So that's essentially primary constructors. You can see this, another primary constructor, or another constructor declared here. And other constructors always have to go through the primary constructor, directly or indirectly, to make sure the primary constructor always gets called, so that the captured parameters, or the parameters in general, are always in scope for the body to use. So that's primary constructors. I want to see if there's a question on primary constructors. All right. Go ahead, Sergey.
No, I said that no questions yet.
Okay, all right. Maybe we just save the questions for the end. Give Shir a little time to think about it. Okay, so next thing is a little more. Primary constructors, you can say it's a shorthand for something that you could have written already. Just makes some patterns of coding a lot more convenient. You don't have to declare so much storage and stuff behind the scenes. The next thing, though, is something that is quite a lot more annoying in C# today. you see that I'm passing in, I have an array parameter for my primary constructor. I'm passing in an array here. I'm passing in an empty array here. If let's say I change my mind, I would prefer this to be a list. So I could say list of grade. Now, because I'm using a different collection type, the way that I'm creating the collections that to pass in no longer works, right? So now I have to say something else. Maybe I can say new. I could say new list of grade and use a collection initializer. We actually allow you to do an implicit new nowadays, so you don't have to say the type. That makes it shorter, but it's still different. And for the empty, maybe there's a list.empty. No, there isn't even a non-generic list here. Maybe it's list of decimal.empty. Let's see. No, there isn't. There actually isn't an empty method for lists. So we have to create. Maybe we just create a new list, and that's the empty one. Yeah, that seems to work. But again, I can figure this out, the ways, but why does it have to be different? And what if I want an even different collection type? Then what do I do? What if I want something that you can't initialize today? So in C# 12, we want to add a common syntax for collection literals, like for creating a new list or a new collection of elements of any collection type. And that's the syntax that we use for that is square brackets. So now you can just put this and the empty one, unsurprisingly, it looks like this. And that'll work for the list of grades that I have here. It will also actually work for something like immutable array, for which collection initializers don't work today, because they depend on mutation, and immutable collections can't be mutated. That's the whole point, right? But collection literals will work for those as well. And of course, they will work for the original type we had here for arrays as well. And so we have this shared syntax for creating collections. And it's not just that the compiler has like a long list of collections it knows about that it'll create. It's also we are making it so that there is a pattern that you can follow when you write your own collection types that will then plug into this, even if you don't, a pattern that does not rely on the thing being mutated. This is another one of those language features that is open to for everyone to exploit. And you can write your own collections so that in such a way that they can be created with collection literals, even if they're not mutable. So we think this is going to clean a lot of C# code up. This is also just nicer, right? It's just nicer to look at. It unifies a whole bunch of different things. And the plans currently for collection initializers is that we'll allow them also to have a spread functionality. So you could say something like, let's say I wanted to steal my colleague Dustin's grades. Grades dot. I think I have a. Hang on a second. I think I have a grades dot Dustin here. I can steal his grades. And so the dot syntax here is a spread operator, right? It takes all the elements in another collection and spread them in as elements in this collection. If you're thinking about where the syntax is coming from, why are we using this syntax? You can look down here at list patterns that we added recently to C# as well, and you can see that there's kind of like a clear parallel between these two. It's actually, we didn't add much new for pattern matching this time around, but it's a general principle in pattern matching that we try to make patterns that we match on, like to sort of like deconstruct an incoming value. We try to make them look similar to the syntax that we use to construct the value. So there's this dualism between constructing and deconstructing. And usually for patterns, the pattern comes later, but for collection literals, it's the other way around. There were already patterns for deconstructing lists or collections, as you can see here. And then, they can have single element things, and there's even the dot syntax to match out all the remaining elements of a given list pattern. And that's completely symmetrical to how the collection literals look. So now we have the symmetry as well. Questions?
Not yet.
Either this is so easy that nobody has any questions, or it's a little hard to chew. I will move on to the next feature I want to show. Let me see. Just remind myself. There's one thing that we've wanted to do for quite a while as well. Sometimes in C#, we are very reluctant to add a new feature because it introduces what we call a cliff, like you can fall over a cliff, where we introduce a very easy syntax for something, and then as soon as that easy syntax doesn't quite do the thing you want, you have to fall off the cliff and use the complicated syntax. And that creates kind of like a break in the experience, if you will. And one of the things that we knew it had a cliff, but we added it anyway, all the way back in C#3, I think, is auto properties. We've allowed a few more things over time for auto properties, but essentially the problem with auto properties, they're awesome until you want to do just the tiniest little bit of extra work in one of the accessors, and then you fall off a cliff and you have to manually declare a backing field and both of the accessors. And we want to smooth out that experience so that if I want to change something a little bit for an auto property, I can in fact go in and, let's say, define one of the accessors myself. Let's say that when I set it, I want to just trim the input before I put it into the backing field. And the way that we allow that is, or we're going to allow that, is that we are introducing a field variable. So field is going to be a special name. You can see this doesn't work yet. I don't have this in my Visual Studio yet. We will introduce a field to represent the backing field of this auto property. And I can then, if I just wanted to do what is always done, I can use the value special parameter and just assign it in. But in this case, I want to just, I want to just trim the white space off of it. So now the idea is that this would now be allowed. Just, I can still leave the getter implemented by the compiler, or I can implement that myself as well if I want to. And I can also, but I still get the backing field. Even if I implement both of them, let's say that I implemented the getter as well, maybe just returns the field. This is still an auto property, even though it has all of its accessors implemented, because it uses the field special variable inside. It tells the compiler, oh no, this is still an auto property. Still generate the backing field. It's just that you're accessing explicitly. So in this case, even if you implement both of them, you still get the benefit of not having to declare your own backing field. And in fact, it's probably going to be very rare that you need to declare your own backing field when this feature comes into C#, because usually you're going to want the backing storage to have the same type as the auto property. Right. So you are the cases where you really need to declare your own backing storage is really for situations where there's a difference in type, or the state is actually represented some other way. So this feels like a nice advancement in C#, but it does have a problem. And so I think with 4 minutes to go before we go into questions, I'm gonna let me just talk a little bit about that problem. So the problem is that referencing something called field inside of an auto property, that's already legal C#, right? There could be another field out here, called field. Let's say that there was, maybe it was even a string, string field. Okay? And now this references that. And so there are cases where this new feature would cause old code to mean something new, to change its meaning. It's not going to be super common, but it's going to exist. There's going to be code out there. Field is not a weird word to use in your code. Certainly, if your variable names and so on are English language. So there are various ways that we could solve that problem so that the field keyword would not be a breaking change in C#. We could make it so that if there's a field there called field, there's something already called field, well, it just means what it already means today. But that's a strange effect, right? If think about the new language after this, is like many years from now, somebody adds something out here called field, and all of a sudden their auto property stops working correctly. That introduces this kind of surprises. We've done that too many times in C# where we've added a feature and made it more complicated than it has to be, just so that some code that could already exist will continue to exist. Think about var, think about name of, think about the underscore for discards. And those have more complicated rules than they have to, just so that we can't break the language. So one of the things we're thinking about, and we're thinking about it hard enough and seriously enough that it might cause us to postpone the field feature here and make it not get into C#12 so we can get this right, is should we change a little bit how we think about breaking changes in C#? We've noticed that other programming languages around us, they have actually more permissive approaches to breaking changes than we do. We think that it's a great quality of C# that we don't go around breaking your code all the time, and we're not going to do that. But when there's this language feature that has a right design that is slightly breaking, or a wrong design that's going to confuse people forever, or cause like weird error states, maybe we should do the right design, And then how can we do that in such a way that people are kept relatively safe when they upgrade to the next C#? That's something that we're looking at right now, and it's still like work in progress. But if we can do that, then there's a chance that we can do these kind of slight breaking changes and have maybe even clean up some of the existing things like var and like underscore, so that they don't have the confusing behavior that they have today. We have evidence that that underscore in particular, the discard, the rules for when a thing is a variable and when it's a discard are so confusing that people aren't using it nearly as much as they could. They're like, I can't tell if I'm introducing a discard right now or I'm declaring a new variable or using an existing variable. If we could fix that with a slight breaking change and then warn people appropriately that there's a breaking change about to happen to their code, then maybe that's a better point to be at. So I wanted to share that thinking with you as well, because that's an ongoing thing that we are focused on right now. So with that, I've spent my half hour. I can certainly talk a little longer if there aren't any questions, but I think this is a good time to switch and see if there are questions now.
Yeah, we have a question. Let me ask. Would it be possible to access backing fields of other properties without declaring them?
So that is one of the things that that would that's true. That's a really good example of a situation where you would need to still declare a backing field explicitly. With this feature, so good point. I forgot to mention that. With this feature, only the property accessors themselves can access the backing field. So if it's unacceptable for other members to use the property and they have to kind of get at the backing field, then this is not a good idea.
Okay, and my question regarding the field, if we use, for instance, we use a entity framework and probably feel this is not like a, should be a common or not a common variable in our solution. And if we use, just in case, if we use field and upgrade our C# and is it, let's say, will it possible to see this notification when we compile the solution, just to be sure that we use field as our own property or variable, and we need to do something to change.
Oh, so you mean if you mean in case, is this related to the breaking change?
Yes, correct.
Yeah, yes. So the thing we're thinking about for the breaking change would mean that you essentially get a warning if you move to a new, or before you move to a new version of C#. We will tell you, possibly this will just happen. We haven't completely designed the feature yet, but as soon as the new compiler comes out, people actually often use a newer compiler for an older language version in the C# ecosystem. That sort of almost automatically happens for most people. And when the new compiler comes out that knows about the new meaning of field, it will still compile the old version of C# correctly, the same way it worked before, but it can then give you a warning because it knows about the new meaning that's that will come if you upgrade. So then it can give you a warning saying, hey, if you ever upgrade to C# 12 or whatever, that this is going to change its meaning. And then it can offer a high quality fix. In this case, it can just say, hey, why don't, if you actually mean that field out there, why don't you just change to this field? And that will protect your code from being broken by the new language version. So the way we're thinking about it is that we want to let you know and help you fix the problem before you go to the new language version.
Yeah, thank you. And one more question from the caller. Let me. What type? How to translate the type of error? I mean, array we use the symbol will be under the hood in runtime. Will the correct type decided during the build process?
Yes. So for this, and that actually brings up something I also forgot to mention. So when there is a type, a target type, you might say, when the expression is being passed as a parameter to something that has a type like here, or assigned to a variable that has a given type, then that type is what determines what code actually gets generated for this. So we might actually, the compiler will generate different code depending on, oh, sorry, you couldn't see the code before. The compiler will generate the appropriate thing for the receiving type. And so the type can really decide, it can tell the compiler, hey, this is how you should create me. Now, what if you just, so there's an interesting question in there that I didn't bring up. What if you just said var x equals and then some collection literal, right? If you don't give it a target type, you just use it directly. 1, 2, 3 here. What does that mean? So that is actually an active discussion. If you don't give a type, should this be legal? Like up until recently, it wasn't legal for lambdas, for instance. Like you couldn't do this with a lambda expression. You had to have a target type. But that's something we actually recently changed. We now have we pick a reasonable type for you. And we think we should pick a reasonable type for you in this case as well, rather than give you an error. But the question is, what is a good type to pick? How can we know which type you meant? And maybe we should just pick something, and that is what the language always does. And if you don't like it, well, give it a type. So we're currently thinking list of T, the generic list type, is a good candidate for that, but we haven't completely closed on that. One concern is that we would like for whatever we do, we would like for it to be as efficient as if you had written your own initialization of the type. And when there's a target type, we can certainly do that. We don't want the compiler to be a bad option. We don't want these collection literals to be a bad option, and it's better for you to write, the specific for the type thing. We want it to be just as efficient, or even more efficient sometimes. Like we can use secret hooks to avoid extra allocations or whatnot. But when we don't know the type, then we don't know what's efficient for you. Like list of T might be your best choice if you are looking to manipulate it a lot afterwards. But if you just want to keep some elements that you're never going to change it, you're just going to iterate over them a few times or something like that. You want it to, you're never going to mutate it. Then the list of T is not the most efficient representation. Then maybe we would do a span of T or something like that and stack allocate the elements even if they're never returned. Or we could do more efficient things. So that's a real question for us. And one of the avenues that we're exploring is, can we actually sort of look at what you're using it for? We say, okay, it's semantically speaking, it's list of T. You can do the same things as you do with list of T. But let's say you create it and never mutate it, never return it. We can make choices about how we can optimize the code and do the same thing that list of T would have done, but without the allocation and so on, without the cost of making it mutable. So these are the things that we're debating currently.
Yeah, thank you. No more question.
All right. Well, given that we are, let's see, we have 4 minutes left, right?
Yep. By the way, I have a question regarding these new new changes. Are all these particular changes also available when, for instance, I use VS Code and I'd like to try these changes, or does it mean what kind of that doesn't mean that I use let's say VS Code or Visual Studio, I mean the whole version, and I can use these changes because I installed new .NET version.
So in general,
yeah.
Do you mean like, can you use them right now, or do you mean when they come out?
No, right now. For instance, I use Visual Studio Code. And,
yes, what we do is that. So I'm not sure what the situation is with VS Code, but the C# compiler itself now has a language version called Preview. If you explicitly go and change the C# language version, instead of put a number, you put Preview, the word Preview, then we will let you use whatever features are currently implemented. Of course, that may change over time. It causes your code to be vulnerable to that, but it's a way to try out new features. I believe that what's currently out is like the alias, using alias thing I showed and the primary constructors thing is currently in preview. And the collection literals, I believe, are not out yet, but soon. I was using like special bits for my demo. And things will come in over time. And then in C#, so in Visual Studio or wherever, if you change your settings so that is your language version, then you should get a reasonable experience. And I know it's reasonable in Visual Studio. I haven't actually tried it in Visual Studio Code, but it might work just the same. Most of the functionality that you're seeing from an IDE perspective kind of comes from the Roslyn layer that Visual Studio is also built on top of, but or Visual Studio Code rather. But you can, I don't want to promise anything here. In Visual Studio for sure, you can do that. So yeah, go ahead and play with the features and see if they how they feel for you, and give us, tell me if you don't like them.
Yeah, sure. And one more question. This is my personal question also. Could you tell us some probably features you plan to do, but for some reason we don't see in the current C# version? You talk about field. Probably you have some more. For some reason you try to postpone and to put some changes?
Well, we certainly, there's a feature we sometimes talk about called extensions, which is one that is very hard to add and very hard to get the design right. So it's probably going to take longer, but a very, very short version of it is that one of the things it would allow is, about extension methods. It would allow other kinds of members to be added as extensions as well. And maybe even you could add extension interfaces. So you could sort of pretend that a type implements an extra interface. It's quite involved. It's difficult to get that feature right, and there's still many open questions. But that's one that we are actually spending a lot of effort on designing right now. It's just probably going to be a multi-release effort before it can make it into the language.
Yeah, I see. Thank you for your time. No more questions, and I'm so excited to see these all features and upcoming features as well.
Excellent. Thanks for having me at your event.
Yeah, thank you. Have a good one.